Hello, folks. We've all seen these wind turbines while driving on highways or across open land. They look calm and simple. In fact, they are complex energy generation plant with complex operating and maintenance needs. Their commercial viability relies on the revenue they generate from energy sold to the grid after all other costs are considered. But do you know how much money they spend? Just for unplanned maintenance. What if I told you one US-based wind energy company saved tens of millions of dollars just by adoption of offline gearbox oil filtration? But how? Why? Nothing complex, simply by cleaning oil. This company is one of the largest wind energy operators in the United States. Their challenge wasn't power generation, it was gearbox failure, because this decision quietly changed the reliability of hundreds of wind turbines. Identified gearbox failure and the associated planned and unplanned maintenance costs as a major contributor to lost profits, and the major contributor to gearbox failure was oil condition. And gearbox failure is expensive, very expensive. At best, up-tower service can be made, but significant loss of production, parts and labor costs are high. At worst, workshop overhaul or total gearbox loss can cost in millions depending on gearbox size and production loss. So watch carefully. In the next 60 seconds, I'll explain what a wind farm really is, what the real problem was, and why inline filtration simply wasn't enough. Let's get started. What is a wind farm? Well, a wind farm is best understood as a modular power station. It can consist of one wind turbine, or hundreds of wind turbines working together. Each turbine contains a gearbox that converts slow blade rotation into usable electrical power. Energy produced and sold determines profit, but only after operation and maintenance costs are deducted. That's why it's absolutely critical. Simply building more turbines that operate inefficiently may increase output, but it's far more effective to maximize the performance of the turbines already in the field. At the heart of most of the world's wind turbines sits a gearbox. And just like our hearts need clean, uncontaminated blood, a wind turbine gearbox needs clean, uncontaminated oil to reliably generate energy from wind. So why is oil such a big issue? What is the real problem? Well, over time, gearbox oil becomes contaminated. Microscopic particles, moisture, varnish and oxidation byproducts caused by heat and contamination. It's widely recognized that around 80% of rotating machinery failure has its root cause in oil-related issues. These contaminants reduce lubrication effectiveness, increase friction, wear and heat, and ultimately lead to failure of gears, bearings, shafts, and seals. At that point, the gearbox becomes unusable, requiring costly up-tower intervention, workshop overhaul, or in the worst case, total replacement. All of this, including lost energy production, could have been prevented. So why haven't these issues already been solved? To some extent they have, through inline filtration, but it wasn't enough. For anyone who isn't technical, let me break this down simply. Inline filters, often called mainstream filters, are installed in the main oil flow. They only work when the system is operating and oil is moving. They're built for protection, not for deep oil cleaning, typically removing larger particles, often 10 microns and above. But they don't address varnish, moisture, or the submicron contamination where over 70% of oil contamination actually exists. In short, inline filtration may slow degradation, but it does not stop it. This is why offline filtration, sometimes called kidney loop filtration, is different. Offline systems work independently from the main oil flow. They continuously clean and polish the oil, even while turbines are operating normally. They remove ultrafine contamination and moisture that inline filters simply cannot reach. If the oil is clean, the gearbox stays healthy. The company ran a pilot program across multiple wind farms. The results were clear: cleaner oil, improved reliability, extended gearbox life. When these results were scaled across more than 2,500 turbines, the estimated savings added up to tens of millions of dollars over time, not by producing more power, but by avoiding failure. This is the type of problem Delta-Xero works on. By filtering down to 0.1 microns, it addresses the contamination that most systems never reach, not only reversing oil degradation, but stabilizing it, and in most cases preventing it from starting at all. Proven performance, maximized operation, just cleaner oil and fewer failures. If you operate critical equipment, and oil reliability matters to you, it's worth asking one simple question: What is contaminated oil really costing us? And if you'd like to explore more real-world stories like this, about oil, filtration and reliability, subscribe to our channel and stay tuned for more insights.